All right, tonight we're going to talk about one of the types of transformations. We've already talked about translations, we've already talked about reflections, and tonight we're going to talk about rotations. And again, it's a rigid transformation. It has it's isometric, so we're just creating another figure with the same shape and the same size. So let's take a look at the definition of a rotation first. A rotation is a turn in a given direction for a given number of degrees around a fixed point. And for the purposes of our notes today, that fixed point is going to be around the origin of the coordinate plane. So the flag below shown below is rotated about the origin 90 degrees, 180 degrees, and 270 degrees. Flag A, B, C, D, E is the pre-image, and then flag A prime, B prime, C prime, D prime, E prime is a 90-degree counterclockwise rotation of A, B, C, D, E. So let's go ahead and take a look at this. So 90 degrees would be one turn about the origin. 180 degrees would be two turns about the origin. And then three turns would be 270 degrees. So we're going to look at how this is represented algebraically. So rules for rotations can be written in the following form, just like we wrote the rules for translations. Rules for rotations can be written in this form right here. Here we're starting out with x, y. We're ending up with here's our pre-image, here's our rotated image, so those are the prime marks. The r of 0 tells us that the origin is the center of rotation. Can that change? Yes, it can. But for our purposes tonight, it's just about the origin. And then the plus minus tells you how many degrees you want to rotate it. And r is the center of rotation. So this is our algebraic representation. So this is how we represent it algebraically. And that's how, so on our example below, we have a rotation about the origin 90 degrees. So unless it's otherwise specified, the standard rotation is counterclockwise. So counterclockwise is going this way. So in that direction. That's counterclockwise. If we wanted to do it clockwise, it would look like negative 90 degrees. That would be clockwise. So let's take a look at the, sorry about that. Let's take a look at this image right here, triangle A, B, C. Okay, so we have triangle A, B, C, D. It has the following coordinate. It's labeled on your graph there. A is at 2, 0, B is at 3, 4, and C is at 6, 4. You can either trace the triangle on the patty paper that I gave you and include the x and y axis, or you can just turn your paper, and that's what I'm going to do on this video tonight. So the first step is asking you to rotate, we're right here, the triangle 90 degrees using the axis you traced to help you line it back up, and we're going to record the new coordinates. Now it's 90 degrees, so it's going to be counterclockwise. So I'm just going to, you can either turn your paper, or you can just trace it with the patty paper. So I'm going to turn it 90 degrees. And there's my new coordinates. So all I have to do is treat this as now we went from quadrant 1 to quadrant 2 and write down the coordinates of the new points. Disregard the points that are on there. So A is at 0, 2, B is at negative 4, 3, and C is at negative 4, 6. And I'm going to record those coordinates over here. So A is at 0, 2, again B is at negative 4, 3, C is at negative 4, 6. So I'm going to go ahead and turn that back to where we started. Okay, and the second one is we want to rotate the triangle 270 degrees using the axis you traced to help you line it up and record the new coordinates. So 270 degrees, if we do 270 divided by 90, that would be 3 turns. So 270 degrees is 3 turns. 90 degrees is 1 turn. And then 180 degrees would be 2 turns, counterclockwise. So we're going to go ahead and do that. I'm going to turn it once, that's 90 degrees. Turn it twice, that's 180 degrees. Turn it 3 times, that is 270 degrees. So our new coordinates for A prime, B prime, and C prime, A is now at 0, -2. B is now at 4, -3. And C is now at 4, -6. And we're going to go ahead and record those coordinates over here. So A, again, is at 0, -2. B is at 4, -3. And C is at 4, -6. And finally, we are going to rotate the triangle 180 degrees. So I'm just going to go put it back where we started. And 180 degrees would be 2 turns. So take your patty paper, turn it once, and then turn it another 90 degrees, turn it twice. So here are our coordinates of our transformed image. A is now at -2, 0. B is now at -3, -4. And C is now at -6, -4. So we'll record those coordinates over here, -2, 0, -3, -4, and -6, -4. So you can either use the patty paper or you can just turn your existing paper, and then just again disregarding the coordinates that are on there, just treat it as if you were in this case, when we did it 180 degrees, we are now in quadrant 3. And that's all there is to it. So keep in mind, again, that when we're talking about a rotation about the origin, the R tells us rotation, this tells us the point we're rotating it about, and that's the origin. And then it'll also tell us if we need to do it 90 degrees, -90 degrees, 270, -270. And again, unless otherwise specified, we are rotating counterclockwise. Okay, so now it's your turn. Here are the 2 Google or video questions. Sorry, I will try not to rotate it. So describe the transformation done on triangle FKW to form triangle RNG. So FKW is our pre-image, RNG is our rotated image. So it's asking which of these, A, B, C, or D, will take triangle FKW and turn it into triangle RNG. And keep in mind the directions for clockwise and counterclockwise. And you could turn your paper to see what will end up, use your patty paper again. And then number 2, unless otherwise specified, is the standard for rotation clockwise or counterclockwise. So little typos there. So, and just check back on your notes for that. Go ahead and put your responses in the Google form, and if you have any questions, you can put those there too. Have a good night.